In this video, we'll look at an introduction to root solving. So what is root solving? The root of a function is defined as the point where that function is equal to 0. For a function with one independent variable, let's say x, and a dependent variable, we'll go with y, then the root is where y in terms of x equals 0. If your function's just a linear equation, then basic algebra can be used. So for instance, the equation of a line here, y of x is equal to the slope times x plus b, and we want to find where that equals 0. We just do some manipulation and come up with x is equal to negative b over m. If you have a quadratic equation, then we can use the common quadratic formula. So if we have an equation of the form ax squared plus bx plus c equals 0, then the solution is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So in general, root solving is trying to find where some function in terms of an independent variable is equal to 0. And it shows up in many different applications in engineering. A couple quick examples here. If we have a linear equation, 2x minus 4, and we want to know where y of x equals 0, do some manipulation, and we find that x is equal to 2, and at that point y equals 0. Quadratic equation, if it's x squared plus 3x plus 2, if we use the quadratic formula here and plug in all the numbers, we end up with negative 2 and 1. And you can see those are the roots on the graph over here. So that is the point where it crosses the x-axis and the function is equal to 0. But for more complicated problems, we need a different set of tools to solve for these roots. So I'll give you an example here. If we want to know where the root of the equation 1.5x squared minus 10 plus 1/2 e to the negative x over 2.5, we can't use the quadratic formula anymore, so we need different tools. And before we dive into that, there are a couple common root solving problems. One is where we want to figure out where a function is equal to a constant. So we want to let f of x be some function and find where f of x equals c. So in order to formulate this as a root solving problem, we can move the constant to the left-hand side here and end up with a new equation we'll call g of x, which is the old equation minus the constant, and we set that all equal to 0, and we now want to solve for the roots of g of x. The next typical problem in engineering is finding the minimum or maximum of a function. So let's call this function p in terms of t, and we want to find the minimum or maximum over some interval including 1/2 up to 4. So we need to find the first derivative of p, and we'll take the derivative in terms of the independent variable t, and we'll call that h in terms of t. And then we want to formulate the root solving problem and find the roots of h of t, which is where the first derivative is equal to 0. So a few examples here. If we want to find where f of x is equal to 2.5, we have f of x and we want to set it equal to 2.5. All we need to do is move the 2.5 to the left-hand side, and we end up with this new equation. And what we want to do is figure out where g of x is equal to 0. So we'll use our root solving technique to solve for that particular set of roots. The next example here is find the minimum of that same equation. So to find the minimum, we first need the derivative. So if you take the derivative of f with respect to x, you end up with 3x minus 0.2 e to the negative x over 2.5. So if we want to solve for the minimum, we let this h of x function equal the first derivative and figure out where h of x equals 0. So if you do need help with derivatives, a pretty cool tool is wolframalpha.com, and you can use that to check your derivatives if you're still taking a calc class.